Okay, I think we're live. Um, uh, I wanted to do a bit of a stream, maybe a sequence of streams about um, some things that are happening in the C programming language and the ecosystem there. There's a couple of new standards, or a couple of new things coming in the new standard, which might be 26 or 27. Who really knows? That's standards for you. Um, so I just wanted to do a sequence of streams. I'm going to try and keep this one pretty small. This is just a couple of days before Christmas, so happy Christmas if you celebrate Christmas, or if you celebrate some other festival around this time, then happy celebration. Today is the solstice, I think, in probably an hour and a half or something in England. And so maybe if you're a pagan, you're celebrating today with a bonfire and some naked dancing or something. I don't know. Um, anyway, do enjoy it. I'm going to try and keep this short and to the point, whilst also showing you something. So I'm going to show you some stuff about there's closures coming to C, which seems incredible, and I feel like it's going to be groundbreaking. It's just absolutely really change the readability of C code, make it much more readable. So what am I doing today? I've got some code on the screen, but maybe first I should show you this. I'm actually working on an Acme client for my web server. And this is all HTTP requests that happen. So you have to fetch a nonce and you have to register an account. You only have to register an account once, but then with the account, with the private key that you pre-created, you have to create a set. And these have obviously got, these are conversations, so it's like this is a head, an HTTP head request, that is one without any body. And what you're getting back is just the nonce value in the header. A registering account is posting an entire JSON document to here and expecting a JSON document in return, and creating a cert is pretty much the same. So that's what I'm doing. So I've been working on this for a while, and you can probably hear I seem to have been ill for months. Um, so I've got a very bad cold now, and earlier on in December I had a horrible flu. So there is a musical interlude played on the nose trumpet. Anyway, so here is some code that is doing the create account part of this. Now, obviously, for any HTTP request, you've got a URL, some request headers, potentially a request body if it's a post, and then you've got a response code coming back from the server. You've got a response code. I mean, maybe you've got an error because you can't even connect to the server, but then you've got a response code and some response headers, which might have valuable information in them, and potentially a response body. Now, in the case of create account, we are expecting to send a request body. It's got the a public form of a private key in it. It doesn't really matter about the Acme use case particularly. And we're going to get back some information in the header and some information in the response, the body of the response. So in this function which I've written, also, by the way, sorry, all of the request and the response bodies, they're all JSON in this example, which is why I wrote this little helper function called JSON post for myself, and I'll show you the implementation in a moment. But I'm mainly showing you this to show how bad it is before I show you how we can do it in closures. And I was hoping that I could implement it in closures, but honestly, I feel quite sick, so maybe I won't do much of that. I might just do 10 minutes or something. Anyway, this takes a URL, which is that, and then it takes the string form of this JSON, and then it's taking this post result, which is mainly the response headers. And the response headers are basically a big string buffer that you can then tokenize into headers. So I think you'll agree there's quite a lot of code, and we have to do all this checking. And then finally down here, we've got an iterator over that string buffer tokenized table. So this is then checking that we have particular headers. Okay, great. But as you can see, it's kind of tedious. There's a lot of it. So what I found out was that closures are coming to C, but actually GNU C, GCC, has had what are called nested functions for a long while. Nested functions in GCC have always been problematic, though, because they're based on stack allocation, and essentially if you have code in the stack, then you can overrun the stack to the point where you can then attack the code. So it's been widely agreed for a long time, I don't know, 20 years, that GNU nested functions are not really a good idea. But I guess with closures coming, I guess that people have been thinking about them, because GNU have introduced this. -f trampoline impla equals heap. What this does is move the nested function, the necessary mechanics for allowing nested functions to be called, into the heap. So with malloc and so forth. And that means it's not using the stack anymore, and it's perfectly safe. So this isn't as good as what is being proposed in the C standards, but it's very close to what is being proposed in the C standards. And so we can start thinking about depending on this for now. Even if closures don't get approved in the next C standard, it feels like they will in the one after. So by 2030, 2032, something like that, we'll have closures probably. And I personally, I feel like there are one or two really good proposals that will mean that they're approved this time. So let me show you the implementation of JSON post, I guess. Here we are. There you can see at the top, this is JSON post, and it takes the URL and it takes the body to send, and it returns this thing. And you can see that this also is quite wordy. This stuff just uses curl. So curl is fantastic. I don't understand, if you're using an HTTP client, I don't understand why you'd use in C. I don't understand why you'd use anything other than curl. It's fantastic. Excuse me. but it's also kind of wordy. So it's kind of difficult to oh, forgive me. It's difficult to do complex things with because you end up having to say, you know, a lot of words and maybe invent types to handle ins and outs. And it feels like every time you do something slightly different, you need a new type, and you've also got memory management. Anyway, okay, so I want to show you what I was building instead. So I guess we'll have a test first. And I've been too sick to try this, so that's why this is a live stream. I'm not trying to do a presentational video here, and honestly, the number of people who seem interested in this stuff seems very small. I'm interested in it. Maybe somebody gets something out of it. So anyway, if we take nested functions as a way forward, or what might soon be closures, then maybe we could do this. Let's say we have an HTTP thing, and we can call HTTP thing with the URL, and you know, maybe that's the size, the request body, and the size still. And this is a post handler. So here's the post handler. So this is more like what happens in, say, JavaScript with a callback. So this callback is now, well, we had a callback before, right? We had a table iterator, but this is now a higher level callback. This is receiving the status code, the headers, as well as the response body. So I feel like that nicely wraps up the response. Inside that, we have another nested function, which is going to do the iteration. So how do we do the slice table iteration? Let's come down here, and there's like that, and we go like this. So let's put this in here. Okay, so this will just be headers, and this will just be iter. I can't remember if we need a semicolon there. And we don't need a void p or user data. So I wonder, do you think we can do this? Slice, next, non-slice, because that's what these things are. And we'll have a slice location. Okay. I'm going to collapse this one. And I'm gonna, where can I get this directory from? I guess I can just use this. This is the URL that I'm using for testing. And so is this simpler? I'm not really sure. If status equals 201L, because that's long. If status is not equal to 201L, then return status. Let's change this to a long. And I wonder, I've yet to show you this bit, so maybe we should go show you this bit. I feel like this is a terrible stream, and I apologise. I already feel like I'm all over the place. Oh. So I was thinking that you could do pretty much the same thing. You could return objects full of so you could return a struct full of pointers to nested functions, thus allowing you to wrap up quite a lot of context. So in here we're taking a slice buffer, which allows us to decide how the slice buffer is being passed around. And then we're using that slice buffer here in a function, and then we're passing that back. Now, this will have all sorts of problems if you don't treat it right. You will have to allocate this buff outside of the call and deallocate it afterwards. But that's perfectly reasonable, and that's the sort of normal way we operate things in C. So this feels, obviously this could have a head and a get and a delete and a put, I suppose. So yeah, this test is making this slice buffer, and okay, so we need to clean up this slice buffer. I think I've got a free. What I normally do is just that. I think I've got a free slice buffer somewhere. Perhaps I haven't. I'll just make one. Let's put it up here. Okay, and that's free SB. Okay. So now this slice buffer will be cleaned up at the end here. And you can see right at the top of the screen, that's actually my no, I don't need that, because I'm calling a function here. I'm calling a function pointer. So the thing is, we probably want this long handler. So if it's not 201, then we're going to return the status. And then we iterate. And I guess we'll just return status here. So we probably want to return, what is this? This is returning an int, and it probably should be returning a long. Because we probably want to go spot location on here. So the other thing we could do though is this. So we could go and then we could turn this back into an int. And we could say this, could we? At least that would let us capture the HTTP status. Okay, so we'll return 0 in the case where it worked, and we'll return -1 in the case where it didn't. Okay, so it feels like we've got everything, and that's not so bad, is it? So it's taking a URL and it's a post. It's taking the post handler from here. Now let's go back up and look in this implementation and make sure we've got this right. So this is request headers, and again it feels like we should probably be passing the request headers in, but let's not worry about that for now. And then we got the post field stuff. And the response header buffer, which we're passing in. That's this slice buffer. And then we're loading, and again, what's interesting here is this is type specific because I'm dealing with JSON, but I feel like we could delegate this quite happily into the function, into the callback function. And then this could be more generic, but still nicely wrapping curl. So it feels like curl is quite complicated, but comprehensive, very adaptable. And what I want most often is not that adaptability. I want something simpler. And of course, many people will say, just program in another language. Well, okay, sure. But don't tell me what to do. If I can get the same level, of adaptability out of C, or nearly the same level, then maybe that's a trade-off I want to make. So again, I'm going to leave this for now, but it feels like that's a doable thing. So we wrapped up all of the mechanics of this. Now let's go look at that. Oh, G544. Okay, it's probably Yeah, it's expecting a pointer. Okay, so I wonder. We definitely need some output at the end here. Let's put the status in as well. Okay, so we'll have OK, and then we'll have HTTP status. Now I think this should work. So let's change our main method and we'll just call test. And then we'll exit 1. Okay, now let's try it. Hey! So some sort of stack use after return. Interesting. So this could be something where we can't do what I want to do. Excuse me, fumbling with this. My death pad just turned off. So perhaps you can't do what I'm saying. $506, $513. Stack use after return. I mean, that makes sense, doesn't it? Let's go look it up. Stack use after return, GCC, template. No, it's not template, is it? It's trampoline. Trampoline impler equals heap. Oh, this is interesting. Okay. Let's see if this. Oh, maybe. Oh, this is just nonsense. Wow. Lots of people having fun with this. Let's go for this top one. So anything about heaps. See, I think you're allowed to pass them down, but you're not allowed to pass them up because it's gone. I mean, how would it track the allocation for this function? I guess. But, you know, we could just take another nested function. So what we could do is go like this. And then we've got a request fn. Oh dear, sorry, I'm so sorry for coughing and spluttering. I just need to wrap this one up. So we've got a request fn, which is this char URL blah 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 blah, right? So we could just take that we could call it handler. And that's kind of like the overall thing. Right, and you'd say if string comp method comma post equals 0, then JSON post XX. Oh, I guess you need all of that, don't you? That's the trouble. You need to pass all of the thing down all of the time. Yeah. That's funny, isn't it? Because instead of now returning a whole bunch of state, we want to pass in a whole bunch of state. But it's kind of interesting though, because that's essentially what a JavaScript thing has to do. If you think about how it works in JavaScript, you're going to, like fetch, for example, you're going to go like this. So you're going to go method is post and body or headers, and you're going to have some headers. Obviously this is not JavaScript, and then you'd have the handler. Obviously the handler is expressed as a whatever they're called, promise. So what would one need if one did it? You'd need a method which could be an enum, couldn't it? You need a URL. And you need some headers. Which we could ignore for now. Whoa! I'm all over the place. and then you need a handler. GCC. So let's read this. Shall we? Like, let's go. Taking the address of a nested function requires special compiler handling, of course, to ensure that the static chain register is loaded when the function is invoked via an indirect call. Okay, so we can take an address. GCC has traditionally supported nested functions by creating an executable trampoline at runtime when the address of a nested function is taken. This is a small piece of code which normally resides on the stack in the stack frame of the containing function. Fairly simple. The trampoline loads the static chain register and then jumps to the real address of the nested function. The use of trampolines requires an executable stack, which is a security risk. To avoid this, because we're storing the trampoline in the stack of the containing function. So obviously, if you can overwrite that, you've got access to the code of the containing function. You can do whatever you like. To avoid this problem, GCC also supports another strategy using descriptors for nested functions. Under this model, taking the address of a nested function results in a pointer to a non-executable function descriptor object. Initializing the static chain from the descriptor is handled at indirect call sites. Okay. On some targets, function descriptors may be mandated by the ABI or be otherwise handled in a target-specific way. GCC also provides its own generic descriptor implementation to support the -FNO trampoline, no trampolines option. In this case, runtime detection of function descriptors at indirect call sites relies on descriptor pointers being tagged with a bit that is never set in bare function addresses. Since GCC's generic function descriptors are not ABI compliant, this option is typically only used on a per language basis, where it can otherwise be applied to the whole program. For languages other than Ada, the -F, what version is this? We don't know. The -F trampolines and no trampolines option currently have no effect, and trampolines are always generated on platforms that need them for nested functions. Define the following hook if your backend either implements ABI specific support. Right, so this is implementer advice. Oh, so this is GCC int. I wonder how much GCC manual. I wonder how much we can get from here. Language standards, extensions. Blah blah blah. Nested functions. Blah blah blah. Right. Nothing about impler. Um, I wonder if we got indices. Trampoline is what we want. Trampoline. Trampoline. Isn't that a Julian Cope song? There we go. Yeah. So it's possible that we can't actually do some of this without redesigning our API. And so given, I just wanted to introduce the subject though. I think we're still exploring, and it makes sense that you can't do some of the things that I was thinking about. I don't know if you could do these with closures. I don't think you could. I don't know if you could allocate a closure on the heap. Anyway, given that I feel terrible, this was just a taster. I'm gonna log off.